Hi geographers, hope you're all okay. This is my first attempt at the Mrs. Mansell's Geographers YouTube channel, so here we go. Welcome, hope you're all okay, hope you're all staying safe. Geography, so part of this section is some new ideas, and I think it's important that I just talk you through it. So I've got my whiteboard, I've got my whiteboard pens, off we go. So you're in the middle, I'm going to show you the sheet, excuse my little drawings there. You're in the middle of doing this sheet, so the bit I'm about to show you the answers to is this bit here. So the causes of the sea level change. So what have we got? We've got two new words. Let me just get I'm just sat down and just getting my phone at the right angle for you all to see. So you've got two types of change, something called eustatic change and something called isostatic change. Now the eustatic change just means one thing. It's the sea level either going up or going down. So if you think of it like this, if you think of it that there's the land and the blue line is the sea level, the ice would melt in an interglacial, so when it's warmer, and therefore the sea level would rise. So all of the water from the glaciers would flow into the sea and the sea level would rise. So there's the line there. So in respect to the land, relative to the land is there, the sea level would rise and would flood some of the land. So if you think about the pictures that you were looking at for the first part of this, you could see the land sometimes being more land because the sea level had gone down, and sometimes there was less land like today. So that would be the sea level rising in the interglacials in the warmer time. Now, in the Earth's history, the sea level has also dropped, and that second lower blue line is trying to show you that. So this is when we're in a glacial, so any precipitation falling from the sky is snow, and therefore that snow makes ice, makes glaciers, forms big chunks of ice that flow all over the land. So therefore, if the water is as snow and in the ice, there is less water in the sea. So the sea level drops. So if we think back to what we've been doing on all our geography stuff so far, we've been looking at the land and how the sea next to it actually affects that land. So erosion here when it's that low, erosion here when it's that high. So we'll come on to features in the kind of the third section of this, if you like. So that's a relatively easy principle. Now, slightly more complex is this one here, is the isostatic change. So this is to do with not the sea level going up or down, and in fact I didn't write this in for you, is the land level going up or down. And you probably think, well, that's a bit weird. The land going up or down, yes, it did, and it is now. So let me explain to you. So here's the land, so the Earth, and here's the ice on top. So, you know, it just looks like it's a chunk of ice, but this would be ice covering big chunks of the Earth. Now that ice is meters and meters deep, sometimes hundreds of meters deep and hundreds of meters wide, and it's exceptionally heavy. What it actually does is it's very, because it is so heavy, it weighs the land down. So that red arrow is showing you that the land actually moves downwards. Now what that means is the land is moving there, but the sea level is actually staying the same. But it looks as if when that land goes down, the sea level has gone which way? Yes, you're right, it's gone up. Now what you call it, because it isn't the sea level actually going up, you call it a relative rise in sea level. So I'll just repeat that again. Here's the land, all of the precipitation falling is snow, so therefore it makes ice. The ice is heavy, it weighs on the land gets pushed down, the sea level stays the same, but it looks as if the sea level's gone up. It hasn't, it stayed the same, it's the land that's moved. So land has moved, sea level's actually stayed the same. Now, we then have the kind of the next stage of this, and this is where now the ice has melted. So we're going really to that graph, I'll just show you that graph there, aren't we? Where actually the ice has now melted. So in the last few thousand years, the ice has melted. Let's go back to the diagram. And because that heavy weight has been taken off the land rises. And it's a very, very slow movement. The land just doesn't just suddenly bounce upwards, you know, on a Tuesday evening, for example, and we suddenly flung upwards a few hundred metres. It happens very, very gradually. So if the land rises, it actually looks as if the sea level has dropped. It's not. It's a relative rise in, a relative drop in sea level. Now, if you look at my diagram, I've tried to show you that. So the land is here, looks as if the sea level's higher, and the land here has risen, and I've tried to show you that the sea level looks as if it's lower. It's not. The land has moved, the sea level has stayed the same, but because the land has moved, it looks as if the sea level's gone down. So that is isostatic. So if it's to do with the land going up or down, it's isostatic. If it's to do with the sea level going up or down, it's eustatic. So I hope that helps for you able to answer these questions here. On the PowerPoint, you've got from, just looking at my screen now, from slides 14 onwards, tells you all that again. Now, I've not put these diagrams on there because you can see it on the screen now. So I would use these diagrams as part of filling in that sheet that you've got to do. Okay, I'll say bye for now.